Hi there, in this video we are going to go over how to solve a system of equations using the elimination method. Alright, so here we are given a system of equations and I have steps all written out for you over here on the left side. So let's just go down the line with the steps while we solve, and then we'll get to our answer. So we have negative 5x minus 3y is equal to negative 7, and then we have 5x plus 2y is equal to 3. Step 1 says to line up your terms, line up your like terms. So here, here we have negative 5x and 5x. Here we have our y's, negative 3y and 2y. And here we have our constants, negative 7 and 3. So lucky for us, our like terms are already lined up. Step 2, multiply the top and or bottom equation by a factor that will get you a leading opposite coefficient. If you have opposite leading coefficients, you can skip this step. So let's take a look at our coefficients and see if we have opposite coefficients. Here, negative 5 and 5, yes, we do. We have opposite coefficients right there. So lucky for us, we can continue to solve. All right, step 3 says to add the two equations, eliminating one of the variables and solve for the other variable. All right, so let's do that. Let's add up the equations. We have negative 5x plus 5x. These are 0. We just eliminated one of the variables. Negative 3y plus 2y is negative 1y. Negative 7 plus 3 is negative 4. Now we can continue to solve. So divide both sides by negative 1, and then we have y is equal to positive 4. All right, and then you can pick whichever equation you want. I'm going to pick the second one, and I'm going to plug in y for 4. Right, so if you look, step 3 says to add the two equations, eliminating one of the variables and solve for the other variable. That's what we just did. We solved and got y equals 4. And then step 4 says to substitute your answer into one of the original equations. So in this case, I'm going to pick the second equation just because I don't have any negatives there. You can pick whichever equation to substitute it back into. So 5x plus 2y, which instead of y, I'm going to plug in 4, is equal to 3. All right, well, 2 times 4 is 8. And then we have 5x plus 8 is equal to 3. So now I'm going to subtract 8 on both sides. And I have 5x is equal to 3 minus 8, which gets us negative 5. Then I'm going to divide both sides by 5. And I get x is equal to negative 1. All right, so my final answer, step 5 says to write your answer as an ordered pair, x, y, and check your solution. So my final answer is negative 1, 4. And what I mean by check is if you plug in negative 1 and for x in both of those equations, and 4 and for y in both of those equations, you should get negative 7 for the first one. You should get 3 for the second one if you plug them in. So, in other words, negative 5 times negative 1 will get you positive 5. Positive 5 minus 3 times 4, which will get you 12. So, positive 5 minus 12 will get you negative 7. So, that does check out. And then if you plug it into the second equation on the bottom, right, 5 times negative 1 is negative 5. Plus 2 times 4 is 8, so negative 5 plus 8 will get you 3. All right, so if you plug in the x values and the y values, you can check your work that way. All right, let's go on to our next example here. We have negative 3x minus 3y equals negative 27, and we have 5x minus 3y equals 13. Step 1 says to line up like terms. Well, we have our x's here, we have our y's here, we have our constants here. Our like terms are already lined up. Step 2 says to multiply the top and or the bottom equation by a factor that'll get you the opposite leading coefficient. Right, look here, guys. We do not have leading coefficients. We have 2 negative 3's, and we have a negative 3 and a 5. All right, so neither of our coefficients are opposites. We want to turn them so that one of them will be opposite the other. So that'll require you to think of what number you can multiply either the top equation or the bottom equation or even both in order to have leading opposite coefficients. All right, so in this case, I'm going to pay attention to the negative 3y's because all I have to do is multiply either equation by negative 1, and that'll make the negative 3y positive. All right, so in this case, I'm going to choose to multiply the top equation by negative 1. So negative 1 times 3x is 3x. Negative 1 times negative 3y is positive 3y. And negative 1 times negative 27 is positive 27. All right, now the second equation, I'm just going to rewrite it as is. So 5x minus 3y is equal to 13. All right, and then I'm going to continue. So step 3, add the two equations, eliminating one of the variables, and solve for the other variable. All right, so now that we have opposite leading coefficients, right, our y's, we have a 3 and a negative 3. Those are our opposite leading coefficients. We are now going to add them. So 3x plus 5x will get us 8x. 3y plus negative 3y is 0. Those cancel. Then we're left with 27 plus 13 will get us 40. Divide both sides by 8, and then you get x is equal to 5. All right, then step 4 says to substitute your answer into one of the original equations. You pick the equation to substitute it into. I'm going to pick the second equation just because it's got smaller numbers. So I'm going to write 5 times, instead of x, I'm going to use 5 minus 3y equals 13. So 5 times 5 is 25 minus 3y equals 13. We're going to subtract 25 on both sides. We get negative 3y is equal to 12, well, negative 12 I should have said. Then we're going to divide both sides by negative 3. And we get negative 12 divided by negative 3 is positive 4. And then step 5, write your answer as an ordered pair x comma y. So in this case, our ordered pair, our final answer is 5 comma 4. All right, so again, this equation, we had to manipulate, or the system of equations, I should have said, we have to make it so that we have opposite leading coefficients. All right, in the last example, there already were opposite leading coefficients, but in this one, there weren't. So that's why we had to make sure that they did have. All right, so moving on to our next example. So our next example, we have negative 4x plus 9y is equal to 9, and then we have x minus 3y is equal to negative 6. All right, well, just by looking at this, do we have opposite leading coefficients? Right in front of here, we have a 1. Negative 4 and 1, those aren't opposite leading coefficients. What about 9 and negative 3? Nope, again, they're not opposites. We have to figure out what number we can multiply one or both of those by in order to have opposite leading coefficients. So here is what we can do. There are many different things that we can do, but I think we should look at these x's. So really you have a negative 4 at the top. How can we get a negative 4 down here at the bottom? What is it that we can do to get a negative 4 in front of that x at the bottom? Right, so, or not a negative 4, I really should say a positive 4. Right, how are we going to make it so that we have a positive 4 and they're opposite so we can cancel out? Well, if you distribute a positive 4 down here, that'll make it so that you do have a positive 4x. And then you have here a negative 12y is equal to negative 6 times 4, which is negative 24. Okay, and then the top we have negative 4x plus 9y equals 9. All right, and now we can continue solving. So we can add the two equations. Negative 4x plus 4x, these are canceled out. And now we are left with 9y's minus 12y's, which gets you negative 3y's. And then 9 minus 24, which will get you negative 15. Okay, and then we're going to divide each side by negative 3, and we get y is equal to positive 5. Alrighty, and then step 4 says to substitute your answer back into one of the original equations. So you pick which equation that you want to plug that into. I'm just going to plug it into the second one because that one looks like an easier equation to work with. So we have x minus 3 times y, or 5, is equal to negative 6. Well, negative 3 times 5 is negative 15. And now we are going to add 15 to both sides. And we get x is equal to negative 6 plus 15, which is 9. So write your answer as an ordered pair, x comma y. So our ordered pair is 9, 5. Alrighty. Let's look at one more similar example to the last couple, and then we'll go over some special cases. All right, so step 1, line up the like terms. Yes, they are already lined up. Our x's are lined up, our y's are lined up, and our constants are lined up. Perfect. Next, we are going to multiply the top and or the bottom of the bottom equation by a factor that'll get us leading opposite coefficients. All right, let's take a look. 12 and negative 4. Are they opposites? No, they are not. Negative 7 and 4. Are they opposites? No, they are not. We need them to be opposites. Okay, so maybe take a look at this 12 and negative 4. I think that there is a way that we can make this negative 4x be a negative 12x. Can you think of a way that we can manipulate the second equation in order to make this negative 4x be a negative 12x? We could actually multiply this by 3. Because when we do that now, this will become a negative 12x. All right, so down here we'll have a negative 12x. 3 times 4y is 12y. And then 3 times 12 is 36. All right, and now we can rewrite the first equation over here. So minus 7y equals negative 11. All right, now that we have opposite coefficients, we can start solving. So we're going to add the two equations. So put a plus sign here. 12 plus negative 12, those cancel out. Negative 7 plus 12 is 5y, and then negative 11 plus 36 will get us 25. All right, and then we can divide both sides by 5, and we have y is equal to 5. Once we get one of the answers, we can pick one of the equations to plug it into. I am going to plug it into the first equation. Actually, I'm going to plug it into the second one because the numbers are a little bit easier to work with. So we have negative 4x plus 4 times y, which is 5, is equal to 12. All right, 4 times 5 is 20. And then we have negative 4x. So let's subtract 20 now on both sides. And we have negative 4x is equal to negative 8. Then we're going to divide both sides by negative 4. And we get x is equal to 2. So step 5, write your answer as an ordered pair, x comma y. So our final answer is 2 comma 5. Alrighty. And now let's get to our special case equations. So here is the first one. We have 2x plus y is equal to 7. So, and then the second one is negative 2x minus y is equal to 6. So we are going to solve this as usual. Check to see, do we have leading coefficients? Yes, we do. We have a 2 and a negative 2, so we are good to go. There's no manipulating any equation. We're fine. So 2x plus negative 2x is 0. Those cancel out. Y plus negative y, those also cancel out. Now, I do not want you to ask me, what do you do at this step? You have to have a number on both sides of the equal sign. So yes, while all the terms on the left cancel out, we can't just leave it with nothing there. So we have to put a 0 there. And now we can add 7 plus 6, and we get 13. Now, does 0 equal 13? No, it doesn't. And this is why, since this is not a true statement, then this would be no solution. You could either write the word no solution, or you can write the little circle with the line through it. Okay, again, because this is not true, right? 0 doesn't equal 13, so it would be no solution. Okay, and then the last example here, we have 3x plus 2y equals 5. And we have negative 3x minus 2y is equal to negative 5. So we're going to check to see, do we have opposite leading coefficients? Yes, we do. Positive 3 and negative 3, those are opposites. All right, so we can go ahead and start solving by adding. So 3x plus negative 3x is 0. Those cancel out. 2y's plus negative 2y's, again, is 0. Those cancel out. We can't leave an empty space to the left of the equal sign. You need to have a number there. So we're going to put in 0 because all those cancel out to be 0. And then 5 plus negative 5 is 0. So because these two on both sides are equal to each other, this is when we would write down infinite solutions or all real numbers. Okay? Any of those, or there's a symbol, the infinity symbol. Okay, so because you have one number is equal to another number, and this is true, all right, then that's when you have the infinite solutions. All right, so you have to write either infinite solutions, the infinity symbol, or all real numbers. All right, thank you for watching. I hope you learned how to solve systems of equations by elimination.